Trigonometry test paper solution. The first test that I'm conducting in the class is tan inverse of root 3 minus cot inverse of minus root 3. Negative argument in terms of cot, cos, secant and cot. So pi minus cot inverse of root 3. Then open the bracket because tan inverse of root 3 plus cot inverse of root 3 will become pi by 2. A pi by 2 minus pi will be minus pi by 2. Next is sum. Tan inverse of root 3 minus secant inverse of minus 2. And the negative argument cos, secant and cot. Therefore, this pi minus secant inverse of 2. Then write the secant inverse of 2 as cos inverse of reciprocal. Cos inverse of 1 by 2. Cos will be 1 by 2 in 60 degree. Pi minus pi by 3. Bring the tan inverse root 3 down now. A pi by 3 minus 2 pi by 3. Because you know tan will be root 3 at 60 degree again. So you get this answer. Next is sum. Tan inverse of x plus tan inverse of y is equal to pi by 4. Find the value of x plus y plus xy. Tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy. Take the tan inverse to the other side, it will become tan pi by 4, whose value is 1. So cross multiplying, you get the value of x plus y plus xy is equal to 1. Cos inverse of minus 1 by 2 plus 2 into sin inverse of 1 by 2. Negative argument here, pi minus cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Substitute the value where it will be 1 by 2, so cos 60, so pi by 3. This is sin 30, so pi by 6. Substituting, you get answer as pi. Cos inverse of cos 680 degree. Normally it will be in radians, but here it's directly given as degree conveniently. So you know it's in the fourth quadrant. It's 720 minus 40 is what will give you 680. So write it like that. Solve the trigonometry part. Even integral. Fourth quadrant, all school taught your children cos is positive. So cos 40. Cos inverse of cos 40 is 40 degree. Tan inverse of sine of minus pi by 2. Sine of minus theta is minus sine theta. So then it will become sine of minus sine 90, which is minus 1. Substituting that value here, tan inverse of minus 1 is minus tan inverse of 1, which is minus pi by 4. A cot 90 minus 2 cot inverse root 3. 90 minus is an odd integral. From you all know from 10th portion, cot 90 minus anything is tan. First quadrant, so it's positive. So tan of 2 cot inverse of root 3. A cot inverse of root 3 can be written as tan inverse of 1 by root 3 using reciprocal function. And where tan will be 1 by root 3? At 60 degree, which is pi by, tan will be 1 by root 3 in 30 degree, which is 2 into pi by 6. So it will become pi by 3. 30 degree is 1 by root 3, yeah, pi by 3. And what is tan 60? Tan 60 itself is root 3. So this has got to have an answer, which is, why is it not writing? No, it's not writing, yeah. So it has to be root 3. Just check it. A 90 minus theta is, cot 90 minus theta is tan theta. And tan inverse of, cot inverse of root 3 can be written as tan inverse of 1 by root 3. Where will tan be 1 by root 3? It will be 1 by root 3 in 30 degree. A 30 degree itself is pi by 6. And substituting will become tan pi by 3, and a tan 60 degree is just root 3, hence the answer will be just root 3. So then next is, you could have also done it as 2 tan inverse of x formula here. You could have also used 2 tan inverse of x and still got the same answer, it's up to you. Cos inverse of root 3 by 2 plus cos inverse of minus 1 by 2, this negative argument pi minus cos inverse of 1 by 2. Cos will be 1 by 2 in 60 degree, which is pi by 3. This will be cos root 3 by 2, which is pi by 6. Just solve this, you get this answer. Tan inverse of 1 plus cos inverse of minus 1 by 2 is a negative argument. So substitute, you get the answer. Tan of 2 tan inverse of minus 1 by 5. You either know 2 tan inverse formula, or you can also write tan inverse of 1 by 5 as theta by 2. So tan theta by 2 is equal to 1 by 5. And then substituting tan into 2 into theta by 2 from here, 2 to get cancelled tan theta, and you know relation between a tan theta by 2 and a tan theta. Tan theta is 2 tan theta by 2 by 1 minus tan square theta by 2. And just substitute tan theta by 2 as 1 by 5. You get 5 by 12 to be the answer. So 2 cos inverse of root 3 by 2. You know cos inverse of root 3 by 2 will be, cos will be root 3 by 2 in 60 degrees. So pi by 30 degree, which is pi by 6. 2 into pi by 6 is pi by 3. Sin pi by 3 is sin 60. Sin 60 itself is root 3 by 2. Then bringing the 2 here and bring the tan inverse, the 2 and 2 get cancelled. A tan inverse of root 3 therefore is 60 degree, which is pi by 3. So cos inverse of 1 by 2 plus 2 sin inverse of 1 by 2. Sin inverse of 1 by 2 is a known value. Just substitute and you get the answer to be 0. So sine of pi by 3 minus sine inverse of 1 by 2, negative argument, take the minus out in this. Sine inverse of 1 by 2 will occur only in 30 degree, which is pi by 6. So pi by 3 plus pi by 6 is 90, sine 90 is 1. Tan of tan inverse of root 3 by 4, solve the trigonometry part, which is pi minus pi by 4. An even integral in second quadrant has got to be minus. And tan inverse of minus x is minus tan inverse of x. So in the place of x, there's tan pi by 4. Substitute that, you get minus pi by 4. Here comes a tan inverse graph, which I wanted to teach you. How to do a tan inverse graph? Let's do a tan graph, or normal tan graph. Okay. Let's not do a tan inverse graph. Let's do a tan graph. And tan 0, 0, tan 90 is infinity. Tan 90 is infinity. Okay, let's do tan of minus pi by 2. Tan of minus pi by 2 is minus tan pi by 2 again, and it's minus infinity. So at can you see at minus pi by 2 it gets to minus infinity. And so then the graph has to be continued like this. It comes like this and goes like this. At pi by 2 it's infinity. At 0 it's 0. At minus pi by 2 it's minus infinity. And so then it goes like this. So let's look at what is happening at tan pi. Tan pi is 0. Tan 3 pi by 2. Tan 3 pi by 2 again goes to infinity. Tan 3 pi by 2 is infinity of minus infinity. So tan 3 pi by 2. Okay, let's do what is tan 3 pi by 2, which is tan 270. And a sine 270 by a cos 270. And sine 270 is minus 1, cos 270 is 0. So you get a minus infinity tan 270. Whether it's minus infinity or plus infinity, it's taken as just infinity. So you have to remember to draw this graph like this. At 3 pi by 2, you have to form the symmetrical diagram like this. It goes to 0, and at pi by 2 it gets to again infinity. Can you understand this graph? This is how we must draw the graph. So by symmetry, that you have to continue at minus pi by 2, again it's at infinity, so it has to come like this. It has to come to 0 and then comes like this. And can you see, this is the graph for a trigonometric function. This is x-axis and this is your y-axis for a trigonometry. But for inverse trigonometry, this becomes the y-axis and this becomes the x-axis. Correct? The domain and range has got interchanged. So from this graph, you have to identify what should be the. From this you can see that a y here ranges between minus pi by 2 and a pi by 2, and it does not include, because it doesn't at pi by 2 and minus pi by 2 it goes to infinity. So you can't include an infinity. So then it's open bracket minus pi by 2 to pi by 2 will be y is an element of, or y lies between minus pi by 2 and a pi by 2. Don't put equal to symbol. This is how your tan inverse graph is drawn, and you have to turn around the paper so that x becomes y and y becomes an x. And therefore, y ranges between minus pi by 2 to pi by 2, and your x, which is a domain, ranges between minus infinity and plus infinity, which means all real number. Therefore, x is an element of all real number. And this is how you do a tan inverse graph. So, if they ask you the principal value branch of tan inverse of x, the principal value branch of tan inverse of x, they ask you domain and range of tan inverse of x, domain and range of tan inverse of x. This is how you must draw and find out the domain and range. I hope you understood. So next question, 16. So that's about domain and range of a tan graph. So 16th is let's do a domain and range of a cot graph. Therefore we'll do a domain and range of cot inverse of x. Let's do the reciprocal function. So you know tan 0 is 0. Therefore cot 0 will be infinity. You know tan 90 is infinity. Therefore cot 90 will be 0. You know tan 180 is 0. Therefore cot 180 will be infinity. Infinity. And cot tan 270 is infinity or minus infinity, doesn't matter. So cot 270 will be 0 and so on. So we're going to plot this graph. Let's see how to plot this. This is 0. This is pi by 2. And this is 2 pi. This is 3 pi by 2. This is 2 pi. And this minus pi by 2. Minus pi. And so on. Okay, so cot at 0 itself is getting to infinity. Cot. The cot function at 0 is getting to infinity. So at 0 it's becoming infinity. And at 90 it is becoming 0. So the graph has to go like this at infinity. So it shouldn't touch the y-axis actually, because it is getting undefined there. It should come like this. And then therefore you know that, and you know at cot 180 it's becoming infinity. So then continue to do like this. Just the mirror image of what we did. We did it from right to left, doing from left to right. And you just have to continue this pattern as I told you. Okay, at you know at 180 it's infinity. So it has to, at 180 it is infinity. At 3 pi by 2 it gets to 0. And then therefore you have to follow this kind of a pattern. Very simple. So then what happens when it is cot of minus 90? Cot of tan of minus theta is minus tan theta, so minus cot 90, which will again be 0 only. Will again be 0 only at 90. And looking at this pattern, you know that cot of minus at pi it will be infinity. So then therefore at minus pi by 2 it's got to be 0. Then obviously this got to come like this, and yeah, so this is the graph for cot. And in case they ask you what is the domain and range of a cot graph, okay? And you know that the x-axis is now going to become a y-axis, and the y-axis is going to become an x-axis. And so to define the domain and range, if you're going to define the y, can you see the graph is existing completely between 0 and pi? And open bracket, because it's going to infinity, open bracket 0 to pi is your y, which is your range. And what about x? X ranges between, can you see that it ranges between minus infinity to plus infinity? So x is an element of R, all real numbers. Okay, so that's what it is, and this is how you do a tan graph, a tan inverse graph and a cot inverse graph. So let's go to 17th question, a domain and range of a secant inverse and a cosecant inverse. Am I recording? Domain and range of a secant inverse and cosecant inverse. Okay, so then y is equal to secant inverse of x. You know secant is a reciprocal of cos, and you know cos 0 is 1. So secant 0 will also be 1. A cos 90 is 0. Therefore secant 90 will be infinity. A cos 180 is minus 1. Therefore secant 180 is also minus 1. A cos 270 is 0. Therefore secant 270 is infinity. And so then like this, we're going to do a graph. This is 0, this is pi by 2, a pi, a 3 pi by 2, a 2 pi. And this is minus pi by 2, a minus pi, and so on. And you know at secant 0 it gets to 1. At secant 90 it gets to infinity. So then therefore it's going to become like this. What about minus pi by 2? A secant of minus 90, you know cos of minus theta is cos theta. Secant of minus 90 is also secant 90, and it's again infinity. So again it's at this it is infinity. So it's going to become like this. This is the graph for secant. Okay, so let's continue with this graph for secant. What happens when at infinity means, at what happens at secant 180 is minus 1. Again, you know from here it's infinity and there it touches to infinity, and so this is the drawing. Similarly, at minus pi by 2, it gets to infinity. So then from here at minus pi, so then the diagram has to be like this. This corresponds to infinity, this corresponds to infinity, and so this is what how you do a secant graph, and the x-axis now becomes a y-axis and the y-axis now becomes an x-axis. And supposing they're asking you to define the domain and the range here is y, and you have to see how the graph is at the range. Can you see there is actually the y, there's no graph drawn in between a pi by 2. One second. So if you look at this graph, you see if you don't define y is an element of, you have a graph between 0 and pi by 2. At pi by 2 it's getting undefined, so you cannot include pi by 2. So it will be, at 0 we do have a graph, so 0 can be included. Okay, so then thus you can have a 0 with the pi by 2 not inclusive. Union, again pi by 2 is not inclusive, till about pi inclusive. Till about pi by 2, till pi you have a graph. Can you see? Where the pi can also be inclusive. Okay, so this, if you're going to break it down into, you're going to look at it from 0 to pi by 2, but at pi by 2 it's getting to infinity, so you can't include it. And then from pi by 2 again you can't include the pi by 2 till pi. And this is the value, as I said, to the right side of the origin is where you have to mark a place, and then you have to define your y. Y is an element of 0 to pi by 2, union pi by 2 to pi. That will be that's where your y will be, which is your range. And what about your domain? See, your x-axis, which is actually this. This is your x-axis, and you really don't have a graph which exists between this and this. There's no graph. So then therefore it doesn't include any values between -1 and +1. It doesn't include any value between -1 and +1. So it's x is an element of all real number other than an interval of -1 to +1. This is an interval, or you can write it as x is an element of a 0 inclusive, all real number will be -infinity. So you can't include a -infinity. So -infinity till -1 close bracket, union 1 to infinity open bracket. Infinity has to be always within the open bracket. So you can either write it like this also. This is about a secant graph. Okay, so hope you're all clear. Next, let's write the domain and range of a cosecant graph. So y is equal to cosecant inverse of x. And it's a reciprocal of sine, and then therefore sine 0 is 0. A cosecant 0 therefore is infinity. A sine 90 is 1. Therefore cosecant 90 is 1 by 1, which is 1. A sine 180 is 0. Therefore cosecant 180 is infinity. A sine 270 is -1. Therefore cosecant 270, sine 270 minus cosecant 270 is -1, and so on. So we're going to plot this graph. Let's plot this graph. This is 0, this is pi by 2, a pi, 3 pi by 2, a 2 pi, a minus pi by 2, a minus pi, and so on. At okay, if you see, at 0 it's becoming infinity. At 0 it's becoming infinity. At 90 it's becoming 1. Where will 1 be? 1 will be somewhere here. So it is coming from infinity till 1, like this. And at 180 it gets to infinity again. Okay, let's look at the negative sign. Okay, sine of -90 is minus sine 90, which is -1. So at this point it's at -1, and 0 it gets to infinity again. So then the graph has to be like this. So this is good enough. You can just do this and leave it like that. You need not have to explore more. And this is your y-axis, and this is your x-axis in inverse trigonometry. Okay, in inverse trigonometry. So let's define the domain and range for the inverse trigonometry. Therefore, your range R, let's look at what will be your range R. If you see, between minus pi by 2, at 0 it's becoming undefined, so you can't include a 0. But you can include a minus pi by 2 and a pi by 2 here. So it's inclusive of minus pi by 2 to 0, open bracket, union, 0 open bracket to pi by 2 with a closed bracket. And this is how your y is an element of. From the graph you can identify. What about x? There is no graph which exists between minus 1 and plus 1 here too. So then therefore again it can be minus 1 and plus 1, but nothing other than that exists. So can we say that the x is an element of minus infinity till minus 1, but minus 1 can be included here, union 1 to infinity. So this is how you define your domain, and this is how you define your range in the case of inverse trigonometry. So all graphs are completed with this. I hope you're all clear. Okay, so let's go to next. Next question that I want to include in the question paper. So this is 18th question. Let's go to 19th question. Supposing prove that 3 sine inverse of x is equal to sine inverse of 3x minus 4x cube. The moment I see this resembles 3 sine theta minus 4 sine cube theta. Therefore, I'll substitute x as sine theta. Theta is equal to sine inverse of x. So I'll take the right hand side, write it as sine inverse of 3 sine theta minus 4 sine cube theta, which itself is sine 3 theta. Sine inverse of sine 3 theta itself is 3 theta. Theta itself is 3 into sine inverse of x, hence you can prove the left hand side. So next question. Similarly, we can have questions like 3 cos inverse of x is cos inverse of 4x cube. Okay, let me do a 3 cos inverse of x. You have to prove that it's cos inverse of 4x cube minus 3x, where x is equal to cos theta. Because it's 4 cos cube theta minus 3 cos theta is cos 3 theta. So x is equal to cos theta, theta is equal to cos inverse of x. So take the right hand side is 4 cos cube theta minus 3 cos theta itself is cos inverse of cos 3 theta, which is 3 into cos inverse of x. So thus you can prove by substitution method. These are called substitution method, as you saw. So let's think of another sum. Find the value of 21st question. No, I would like to go for some other sum. Tan pi by 4 plus half cos inverse of a by b plus tan pi by 4 minus half cos inverse of a by b is equal to 2b by a. You have to prove this. Okay, and half cos inverse of a by b. So take the left hand side, you have this. You don't want a half cos inverse. So thus assume cos inverse of a by b as 2 theta. Cos 2 theta therefore is a by b. Cos 2 theta therefore is a by b. So then substituting here, it's tan pi by 4 plus half into cos inverse of a by b itself is 2 theta. 2 and 2 get cancelled, it becomes theta. Okay, tan pi by 4 plus theta plus tan pi by 4 minus the same thing. This will become half into 2 theta again, it will become theta. So it's type tan pi by 4 plus theta, and this is tan pi by 4 minus theta, which is tan A plus tan B by 1 minus tan A tan B plus tan A minus tan B by 1 plus tan A tan B. Tan pi by 4 is 1 plus tan theta by 1 minus tan theta by 1 minus tan theta by 1 plus tan theta. So then therefore you can take an LCM, which is a plus b into a minus b, 1 minus tan square theta. It become 1 plus tan theta the whole square plus 1 minus tan theta the whole square. So when you expand this, you will get a 2 plus 2 tan square theta, which is 2 into 1 plus tan square theta by 1 minus tan square theta. And you all know cos 2 theta is 1 minus tan square theta by 1 plus tan square theta. Okay, so this is a reciprocal of that. Can I write it as 2 by, therefore can I write it as a 2 by a cos 2 theta, a 2 by cos 2 theta. And what is cos 2 theta? Cos 2 theta itself is a by b. Therefore 2 by a by b, or in other words 2b by a becomes the answer, and that's, you have proved whatever they want to prove. It's a very interesting question. So the next question that I would like to discuss. Prove that tan inverse, next question number is 22. Okay, 22. Tan inverse of 6x minus 8x cube by 1 minus 12x square minus tan inverse of 4x minus 1 minus 4x square. You have to prove this to be equal to tan inverse of 2x. Okay, so then as soon as you see this, you know this is like, can we convert into 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So in that case, it's 3 tan theta minus tan cube theta by 1 minus 3 tan square theta. So if I write it like this, then I understand that 2x has to be equal to tan theta. That's when I can write it like this. So theta will be tan inverse of 2x. So then therefore this will become tan inverse of 3 tan theta minus tan cube theta by 1 minus 3 tan square theta, which is tan inverse of tan 3 theta. Tan inverse tan get cancelled. 3 into tan inverse of 2x. So I've sorted out with this. Now let's sort this out. Minus tan inverse of 2 into 2 tan theta by 1 minus tan square theta format, where I have to split it like this. That's when I'll get it. In that case, in this case I can assume 2x is again tan theta, tan inverse of 2 tan theta by 1 minus tan square theta, which itself is tan inverse of tan 2 theta, which itself is, this is minus tan inverse of tan 2 theta. This and this get cancelled. So it will be minus 2 into, what is theta here, is again tan inverse of 2x. So then subtracting, we get tan inverse of 2x. So identifying this to be, is again substitution, but it's quite a little tricky substitution, that's all. So that's what it is. And then next, what can I give you? I think that should be sufficient. Okay, if you can do all these sums and master these, I'm sure that is sufficient. Okay, so this is what is, there are 22 sums which will be given as a test to you, and you should have answered these, and if you've not answered it, make sure that you are going to learn all those. So let me write as inverse trigonometry, inverse test 1. So I'll just save this and upload it.